Hey everyone. So in this video, we are going to show you how to solve a linear system of equations using the matrix inverse. Now, at the basic algebra level, people are probably familiar with how you take a system of equations, in some cases, a system with say a variables x and y, and how you solve that system of equations, right? Now, using a matrix inverse, right, you can do the same thing. And actually, when in real life you encounter systems of equations which have hundreds of variables and there are hundreds of equations, this is how mathematically these systems are solved, right? All right. So let's look at this simple system of equations you see on the screen, right? So you have 1x plus 2y equal to 4 and 2x plus 1y equal to 2. So your variables that you need to solve for are x and y. Now let's solve this system using a conventional, 2 by 2 system solution technique that most people are familiar with from their basic high school math. So what you do is you take, the second equation, which is this, and you multiply that by 2. So what you end up with is 4x plus 2y equal to 4. Now what you can see is you have these two y's here. So you eliminate these two, right? And so what you do is you say subtracting equation 1 from 2, right? And so when you subtract that, you get 4 minus 1 is 3x, 2 minus 2 is 0, and 4 minus 4 is 0. So you get 3x is equal to 0, which tells you that x is equal to 0. Now that you've solved for x, what you can do is put x into this equation and solve for y. So what do? You say, okay, putting x into equation 1, right, which is this equation, this term goes to 0. So you get 2y is equal to 4 because 1 into 0 is 0. And so you get 2y is 4, which means y is equal to 2. So you found out that x is equal to 0 and y equal to 2, right? So this is a very simple way to solve a 2 by 2 system of equations. So now what we're going to do is we're going to take the same system and now let's see what you can do using basic ideas of matrices that we've seen in some different videos on this topic. So what you can do is first you can rearrange this system of equations into this form. So what have we done? We've taken the 1 2 2 1, which are the coefficients to the variables, out and put them in a matrix where it's 1 2 2 1. We've taken the variables and put that in a column matrix x and y, and we've taken the right hand side and put that in a column matrix 4 and 2. Now why is this, that is this matrix formulation, equal to this? Well, think about it, right? You are probably familiar with matrix multiplication. If not, please go check out one of our videos on matrix multiplication. But what you get here is you get 1 times x plus 2 times y equal to 4, and 2 times x plus 1 times y equal to 2, right? If you just multiply through this. So what we've basically done is taken this system of equations and put it in matrix form. Now we can label this, right? So we can say this matrix is matrix A. We can call this column matrix X, and we can call this column matrix D. Now in some cases you will see people using the notation B, AX equal to B. That's fine. I've just used D here for convenience. Okay. So what you're actually trying to solve is AX equal to D. All right. So now what have we done here? We've taken this system of equations that has two variables and converted it into something that actually looks similar, and it's not the same but looks similar to an equation with one variable, right? If you're familiar with basic algebra, you've probably seen how you have a simple system with a scalar a scalar x, a variable x equal to a scalar d, and you say x is equal to d by a, right? That's how you do basic algebra for one variable. You've got it into that exact same format here, right? Where a is 1 2 2 1, it's a matrix. So now what we do is we compute the inverse of this matrix, right? So we say A inverse, and I'm not showing you the solution here. I'm not showing you the steps here. I'm just showing you the solution. But please check out, our other videos on how you compute the inverse of a matrix, right? Right. Assume you compute this, using elementary operations. You can also use determinant techniques and other ways as well. So this is the inverse of the matrix, right? So now if we take the equation Ax equal to D, and on the left side, on the left and the right hand side, we pre-multiply. When you say pre-multiply, you're multiplying to the left of the terms by A inverse. You have A inverse, this term which is A, x equal to, you have to do the same operation on the right hand side, right? If you remember what we did with elementary operations, if you have to apply an operation, you have to apply it to both sides of an equation, right? If it's an equation, so pre-multiply the d term also by that. Now what we have done here is we've done, if you look at this, and I'll show you both the left hand side and the right hand side. We multiplied this by this. Now we know that this is A and this is A inverse, right? We just computed it. So we know that A times A inverse, or A inverse times A, is the identity matrix. And you can just go ahead and try multiply this out and you should get the identity matrix, right? So that's that. On the right hand side, right? Now when we do this in practice, right? So when we are actually solving it in real life, we don't need to do this step because we know it's the identity matrix. It's A inverse A. The right hand side, what you get is A inverse times D, right? So let's multiply this out, right? You take minus 1 by 3 times 4 plus 2 by 3 times 2, which becomes 0 because it's minus 4 by 3 plus 4 by 3, right? Please take a piece of paper and feel free to try to do this, right? And then the second term here, so it's 2 by 3 times 4 minus 1 by 3 times 2, right? So what's that? That's 8 by 3 minus 2 by 3 is 6 by 3, which is 2, right? So you get 0 and 2. So now in real life, this is the step you have to do. Compute the inverse of the matrix A, right? And then multiply that by D and you get this term, right? So when we put it back together, this was the left hand side and the right hand side. By using the matrix multiplication, we've got identity xy is equal to 0, 2, which as you can see means 1 times x is 0 and 1 times y is 2, which means x is 0 and y is 2, which if you remember what we did in the first, right at the beginning of the video, we solved it using a simple, simple technique that is you're familiar with from basic algebra. We've got same answer, right? So this is how you use the concept of matrices and the inverse of a matrix to solve for a system of equations. Okay, so let's just do this again using a little more general notation so that this becomes clear, right? So let's take a system now. We've got three equations. Now here A1, B1 and C1 and D1, and similarly A2, B2, C2, D2 and A3, B3, C3, D3 are just constants, right? I've just used placeholders, right? It could be any set, any number that you use here, but I'm just using these, right? And X, Y and Z are our variables we're trying to solve for. So as you can see, it's a system of three equations with three variables, right? So it's a square system, which means we can solve for it. So we again break it down into matrix form. We've got this matrix which we called A in previously. You have our X here which has the variables, and you have D here, right, which is the constants or the right hand side terms, right? Okay. So now what we need to do is think of this, right, like I said before, as for a simple case, an equation with a single variable, right? So if X was a simple variable, right, one dimensional variable, not a matrix, A was a constant, a number, and D was another number, and we were solving for this for X, what would we do? We'd just do X is D by A. So the inverse effectively does that operation for you. The only thing is you cannot divide a matrix by the other, right? If you're familiar, we have covered in different videos matrix multiplication, matrix addition. We've never covered matrix division because it's not possible to divide a matrix by the other. That's what the inverse effectively does, right? You compute the inverse, which is effectively, it's not really that, but it's effectively like 1 by A. So the inverse of A is effectively 1 by A, and so A times A inverse gives you identity, right? Just like A by A gives you 1. So we've got this system now, right? So say A and X equal to D. So how do you solve this? You say AX equal to D, you compute A inverse and you pre-multiply that. So that's the step actually that you end up needing to do. Computing A inverse. Once you assemble it in this form, you compute A inverse. Then now mathematically how this is derived is you pre-multiply this line with A inverse on both sides. We know this is identity. So you'd end up with Ix is equal to A inverse D, or X is A inverse D, right? So in a practical scenario, what you do is you just take the system of equations, convert it into this form, take this matrix A and compute its inverse. Once you compute its inverse, you multiply D by A inverse to get X. So this is one interesting way of solving a system of equations, and quite a few uses of this. Um, and in advanced math or advanced linear algebra classes, you'll start seeing how this is done, and in practice, how this thing is actually done, which is a little different because computing the inverse, as we've already seen in different videos, is fairly sophisticated. And for 3 by 3 and 4 by 4 and so on matrices, it's doable. But when you start hitting matrices with hundreds or thousands of terms, it becomes complicated. But we're not going to go there, right? Okay, so let's do one more example, right? Just to clear this concept, right, for good. So we've got a system here 1x plus 1y equal to 2 and minus 1x plus 1y equal to 1. Now you can already see here, you just have to add these, you get 2y is equal to 3 and so on, right? But let's use the matrix form. So taken this out, you've got ax equal to d, right? Okay, so x is a inverse d, we already know that. So what's a inverse? It's this. And again, I've computed this. Please go and try it out on a piece of paper and you get familiar with inverse. And if you have any doubts with this, check out our previous video on computing the inverse. So this is the inverse. You multiply that by 2, 1 and you get 1 by 2 and 3 by 2. Now, in this particular case, it's very easy to check because if you just add these two equations, and that's why I've used this, you just add equation 1 and 2, you get 2y equal to 3 or y equal to 3 by 2, which you see here. When you put y equal to 3 by 2 in this equation, right, you get 1x, right, plus 3 by 2 is equal to 2, or x is equal to 1 by 2, right? It's 2 minus 3 by 2. It's 2 minus 1.5 effectively, which is 0.5 or 1 by 2. So x is 1 by 2, y is 3 by 2. So it's a very interesting, simple way to solve a system of equations. So hopefully this is now very clear to you, and you're starting to see an application of matrices, right? We've got a lot of videos, and at different levels you'd study about different operations on a matrix like multiplication and addition and transpose and inverse and so on. But you're starting to see here, where this comes in handy in other mathematical problems, right? In other types of problems. So hope that's become clear. And so now to kind of, reinforce this concept, please go take a quick test on teacher.com. So we've put a quick test for you there. It's a free test. And I've put a screenshot of that here. So to take the test, you can scan the QR code or you can go to this link, and we've dropped that link in the description section and the comment section of this video. So please feel free to go and take the test. And that should give you a little more, understanding of the topic, should clarify any doubts. And at the end of the test, you'll get some feedback and learning on the topic. And please subscribe to the TeachYaar YouTube channel.